Have you ever wondered what makes a clock tick? We're surrounded by these marvels of engineering, from the wristwatch we wear to the grandfather clock that stands majestically in the corner of the room. Yet how many of us truly understand what goes on behind the face of a clock? Our journey today takes us into the heart of these timekeepers to delve into their intricate mechanics. Stay with us as we uncover the mechanics of a clock piece by piece. The mainspring, often considered the heart of a clock, plays a crucial role. It's a marvel of mechanical engineering, a tightly coiled strip of metal that stores energy when wound. Just as a heart pumps blood to power the body, the mainspring releases this stored energy to power the clock. Imagine winding a clock. Each turn of the key tightens the mainspring, forcing it to store more and more energy. This is akin to a heart filling with blood, ready for the next beat. The mainspring then releases this energy in a controlled manner, like a heart releasing blood into the body. This energy then drives the clock's gears, causing the hands to move and the clock to tick. Just as the heart is essential to life, the mainspring is essential to a clock. It's the force that keeps the clock ticking, the heartbeat of the mechanism. The mainspring sets the stage, but what happens next? Let's delve into the escapement. The escapement, acting as the clock's regulator, ensures the mainspring's energy doesn't run out too quickly. It is akin to a traffic officer directing the flow of energy from the mainspring, ensuring it is released in an orderly and controlled manner. Now, imagine a bustling intersection teeming with cars. Without a traffic officer to control the flow, chaos would ensue. Cars would dash off in all directions, and the intersection would quickly become a jumble of metal and confusion. This is what would happen if the mainspring's energy were left unchecked. However, with our traffic officer, or in this case the escapement, we have a sense of order. The escapement regulates the energy release, allowing only a measured amount to pass at a time. It's like having the traffic officer signal one car at a time, maintaining a steady and smooth flow of traffic. The escapement's job is not just to control, but also to maintain. It ensures that the energy release is not just orderly, but also consistent. The escapement keeps the mainspring's energy flowing at a steady pace, preventing any sudden surges or stops. It's like the traffic officer ensuring that the cars keep moving at a steady speed, preventing any sudden accelerations or halts. With the mainspring and the escapement working together, we're almost at the finish line. Now, the pendulum takes the stage. The pendulum, often visible at the bottom of a clock, plays a key role in timekeeping. The pendulum, it's not just there for decoration, it's the heartbeat of a clock, the steady rhythm that keeps the time. Working in perfect harmony with the escapement, it swings back and forth, never missing a beat. Think of the escapement as the conductor of this grand symphony. As the pendulum swings to one side, the escapement releases a tooth of the gear, allowing it to move forward by a small amount. Then, as the pendulum swings back, the escapement locks the gear in place. This back and forth, this to and fro, it's the very dance of time itself. Now imagine the pendulum as a metronome. If you've ever played a musical instrument, you'll know that a metronome keeps a steady rhythm just like a pendulum. It ticks and tocks, marking the tempo, making sure that all the notes are played at the right time. This is exactly how the pendulum works. It ticks and tocks, swinging at a steady rate, making sure that every second is counted correctly. This simple yet ingenious mechanism, the pendulum and the escapement, they are the very soul of a clock. They are the timekeepers, the rhythm makers, the pulse that drives the hands of a clock. With the pendulum, our journey through the inner workings of a clock comes to an end. The clock, a marvel of mechanics, works through a symphony of parts. The mainspring, the heart of the clock, stores the energy, while the escapement, the brain, controls the release of this power. The pendulum, the clock's steady pulse, swings to keep the rhythm of time. Each part, in perfect harmony with the others, creates the rhythm that measures our days. And that, dear viewers, is the magic behind the simple tick-tock of a clock.